You're sitting in your first year biology lecture, blissfully unaware. And then it happens. Your professor mentions Python, not the snake, the coding language. You shrug it off. I'm not a computer science major, you think. But then, chemistry, physics, psychology, even economics professors, they all say the same thing. Open your Jupyter notebooks. You didn't choose Python. Python chose you. This was me too, some time ago. I had completed my bachelor's in civil and structural engineering without writing a single line of Python code. Traditional civil engineering did not require code, and I associated code with only computer science, electrical, mechanical, or electronics engineering. Then 2021 came around, and I began my master's program. In my first semester, I had to learn and use Python, MATLAB, and TCL. It was a bit overwhelming, to be honest. And then I realized it was not just me, it was biology students, chemistry students, psychology students, and most shockingly, medical students. Python was rampant, and I was blown away. The reason Python is inescapable might be obvious, but I would like to cover it in this video.
And I show up to that class, and we have to do Python, which I had no idea. I had no idea what Python was.
Nowadays, you can take machine learning components and sort of plug those things together.
Magical devices we call phones and software everywhere to give me this illusion that I could create something by myself from the basics inside of a weekend like that. I mean, that was a culmination of...
Here are the reasons you would not be able to escape Python as a science student. Python began in the late 1980s as a side project by Dutch programmer Guido van Rossum. Fast forward 35 years, and it's the most cited programming language in scientific papers today. But this is not the only reason Python is so rampant. The other reason is that data and algorithms are pushing the frontiers of what is possible in different fields. For example, in structural engineering, some complex interactions and processes are simply difficult to model with simple formulas. Data from existing buildings can be investigated using Python, and algorithms can be used to come up with new and interesting insights and formulations that can better model these complex interactions, thus leading to better, safer, and more economical building designs. One of my housemates was a biochemistry student. Her research was on figuring out the genes in a certain family of plants that were responsible for a certain mutation. I do not know the details, but she was working with vast amounts of data and running genetic simulations. This sort of research would have been impossible without computers, but it would also be extremely difficult for a student without friendly programming languages like Python. One benefit of Python is that it is unusually human readable. Even other beginner-friendly languages, like JavaScript, expect you to wrap your brain around unusual patterns and complicated syntax, like in this snippet of JavaScript. The same thing can be communicated in Python with a much more readable syntax, combined with descriptive error messages, which is a good thing, great documentation, and a supportive online community. Python has become highly accessible for beginners. I know another student who loves science and does not necessarily love math, so he decided to study medicine. He too is having to implement some Python code to solve a myriad of problems. My friends in the physics department are using VPython for visualizing particle trajectories, chemistry, RDKit for molecular modeling, environmental science, EarthPy, and raster data analysis. The list goes on. Recently, I also noticed that investment banking analyst role job postings that used to be all about financial analysis and brute force use of Excel and PowerPoint now have Python programming listed as a nice to have. In a few years, no doubt, it would become a requirement. My point is, if you are a science student today and you see yourself working with numbers or some sort of data long-term in your profession, it might be a good idea to consider learning Python. And there are lots of free resources on YouTube and other platforms that can help you get started. One very popular one I have received as a recommendation from multiple people is 100 Days of Code, the Complete Python Bootcamp by Angela Yu. It is a great resource. I recommend it. Now that we have talked a bit about science-inclined courses, let us explore art and social sciences a bit. Do you think that you can escape Python because you are studying psychology? You'll be running experiments with PsychoPy, which is a Python library designed to let you build and run behavioral experiments in neuroscience, psychology, psychophysics, and related fields, even in economics, game theory simulations, Monte Carlo methods, agent-based modeling, all written in Python. As machine learning has found its way into different professions, so has Python. And this is because Python is the go-to language for machine learning. I have spent some time on Google Scholar searching for machine learning related research in different fields, and it did not matter where I looked. I found some papers implementing machine learning algorithms on some data relevant to the subject matter, from economics to finance to engineering, and most surprisingly to me, even construction management. So as not to make this video too long, it is slowly coming to an end, but I believe you guys can see what my arguments are as to why it might be a good idea to learn Python. Let me know your thoughts in the comments section, and if you want to see my video on how AI is taking over music, click here to watch it, and I will see you there.